I never go and watch myself, the whatever I've recorded. I don't believe in shock sendiri one. Okay, so I have got 50 centimeter cube, 1 mole per decimeter cube hydrochloric acid. And I got 50 centimeter cube, 2 mole per decimeter cube hydrochloric acid. What is the difference here? What can you see that is different here?
Change in mole.
Change in molarity, not mole, yeah?
Molarity, yeah.
Okay.
Sharon is asking whether she should put the attendance in the group now or what.
Yeah, can put ready. Okay, thank you,
Okay.
Renat. Okay, so here I have 2 different molarities. So which one will be higher? 1 higher than 2 or 2 higher than 1?
One higher than 2.
Very good. 1 must be higher than 2 because 1 I got 2 mole and 2 I got 1 mole. So the first part of the graph, 1 must be higher than 2. So which one can I cancel?
B and yeah, B. B and C. Yeah.
B and C, B and C, because C also 2 more than 1, so B and C cancel. Okay, now the only thing I have is A and D. Renat, Afiq just came in, yeah? Alright, so I want to compare A and D. Now, how teacher want to know? Teacher, do they meet together like D or are they separated like A? Renat Tinesh also just came in. How do I know? How would teacher know? Here, I must calculate the number of moles, okay? Now, each one of you calculate for me the number of moles for the first one. Bernard Adi just coming in. Okay, the first one, MV over 1050 times 2 over 1000. What do I get?
0.1 moles.
0.1 ke? Yes, correct. 0.1 mole, correct. And then the other one, 50 times 1 divided by 1000. What do I get?
0.05.
Okay, 0.05. Are their number of moles different?
Yes.
Okay, when teacher want to find volume, I must times with 24,000 because I want to find in centimeter cube. Okay, all of you times 24,000. Actually, from the number of moles already, I should know. Okay, from the number of moles already, I should know. Calculate for me. What's
Sure.
the first?
So the answer is A, is it?
Wait, wait. What's the calculate for me? How much? 0.1 times 24,000.
24,000.
2,400.
2,400.
Okay, 2,400 is going to be 1,200, right? So can you see the volume is different?
Yes.
Okay,
Yes.
therefore, your answer must be A. Are we clear?
Yes, yeah.
Okay, good job.
Yes, sir.
So you always must calculate the molarity, the number of moles here times with the volume to find out whether they meet or they don't meet. But actually, I want to tell you, you look at the question already, you can know whether they meet or they don't meet. Here I got 50 and 1 and the other one 50 and 2. You sure know they don't meet. Kalau both of them is 50 and 1, 50 and 1, will they meet?
Yes, sir.
Yes, they will meet. Okay, if this question was 50 centimeter cube, 1 mole per decimeter cube, then correct, they will meet. Okay, then you will get D, but now it's not the same, so cannot. Okay, let's go to question 32. Here is 25 centimeter cube, 0.1 mole per decimeter cube hydrogen peroxide solution. Okay, here I'm using 25 and 0.1, okay, for P. If I repeat this experiment using another solution, which solution will produce the Q? Okay, which solution will produce the Q? What do you think is the best answer? Do you know how to do or you boliao don't know how to do? You elect, don't know, elect.
Elect.
Okay, the first thing that you need to do is you need to find for me my number of moles first. Okay, before I talk about number of moles, for P is 0.1, right? So if I want to get Q, now Q has a higher rate of reaction. So that means Q, my molarity must be more than 0.1. All of you agree?
Yes.
Yes.
So it is, you look at all also 0.15, 0.15, 0.15. So every answer also can. Okay, how to know what is my answer? Okay, I need to decide here at this part here. How do I do it? I just showed you in the above question. How to do this question? Now, each of you for A, B, C, and D, go and find for me my MV over 1000 for A, B, C, and D. Go and give me now. MV over 1000 for A, B, C, D. All of you go and give teacher now. Calculate. Use your hands and calculate it. So that means for A, 25 times 0.15 divided by 1000. What do I get?
A is 0.00375.
Okay, good. Don't round up. I want to see the complete answer. Okay, B. I don't want Jeff to be my only student today. Where's the rest of you?
0.003.
0.033.
Which
B.
one for B, is it?
B.
Yeah,
Okay, who said that?
finish.
Why the name doesn't come out? Okay, carry on. C.
0.00225.
Okay, 0.00225. Very good. Now D.
0.0015.
0015.
Okay, very good. Now what I want to do is I found the number of moles. Now I want to calculate the volume. So what do I need to do to calculate the volume for each?
Times 24,000.
Very good. So each one of you now go and times 24,000 for each of this.
So A is 90.
Okay, wait. A is 90. B is?
720.
Huh? Sorry?
720.
Are you sure A
700,
is
yeah.
70? Or 900? Check. Maybe the zero, I put too many zeros here. Double check. 25 times 0.15 divided by
Sure, it's
1000.
90.
90, sir. Oh, 0.0375. So when you take out 1 0, it become 900.
No, what I mean is 25 times 0.15 is how much? 25 times 0.15 divided by 1000. 0.0.
So 0.00375, correct.
Oh, okay. So 90 lah. Okay.
90.
Right. But why so much difference? Then the other one, 20 times 0.15 divided by 1000. This one is wrong. It's 0.003. Did y'all see the mistake there? Are you following what teacher is saying?
Do you mean
Yes,
the
sir.
gap difference, Alicia?
No, the
Are
B
you telling
just
the
now,
gap difference?
the B, y'all told me 0.03. Supposed to be 0.003.
It is 0.003, what? No?
That's not teacher.
0.003.
Tadi cikgu letak 0.03 only. There's a mistake there.
Oh.
Okay, so times with 24,000, you actually get 72, right?
Yes, sir.
Okay, next one, C.
54.
54.
Okay, 54 and D.
36.
Okay, 26.
36. 36.
Okay, 36. Okay, now what I want to do is I want to ask you to now go to this question here, 25 times 0.1, where teacher is circling. This is for for P. You go and find out for P. 25 times 0.1 over 1000. What is my number of moles?
0.0025.
0025.
Okay, now times 24,000.
60.
60, is it?
Yeah, yeah.
Okay, so I know that my P is 60. Now, my Q is not half of P now. My Q is very close to my P. No, so now I need to find the value of Q that is lower than P. So if you look at A is 90, can?
Cannot.
Cannot. If I look at B, 72, can?
Cannot.
Cannot. If I look at C, is 54, can or not?
Can.
Can. If I look at D, it's 36, it is lesser, but it's almost half. But my Q is not almost half. So what should I do? Which is the best answer?
C.
C.
C is my best answer. Okay, can you see here? It seems that my D also can, right? But actually the answer is C. Can you understand, class?
Yes, sir.
Okay, very good. Does everyone understand what Panshina just did?
Yes, yes.
Okay. So far only 3 people said yes. The rest of you?
Yes, yeah.
Okay,
Yes.
even Muhyiddin Yassin also said yes. Well done. Okay, the next answer for question 33. Okay, I'll give you the answer straight away. Actually, all you have to do is you divide. Okay, and then if you divide the 350 divided by 5, 200 divided by 2, 120 divided by 6 minutes, you make it over in 2 hours. Okay, you'll find that C is the best answer. Okay? Boleh?
Boleh, cikgu.
Okay, next. When the temperature of a reacting mixture increases, the rate of reaction also increases. Now I'm talking about temperature. So which one explains the rate of reaction increases? For temperature. Okay, which one is the best answer? Renette, Farid just came in. Okay, sorry, I heard somebody's answer. Good job.
C.
C is correct. Whenever you see the word temperature, you must have the reactant moves faster and they collide with one another. Good job. Okay, Chia. And for all those of you who have been answering me, well done. Okay, 35. Okay, I've got zinc powder and hydrochloric acid. How can the rate of the production of hydrogen be increased? Whenever they ask you anything about rate, you must only remember the 4 factors that I taught you. Okay, let's go to A. I increase the size. Do I want to increase a size or do I want to decrease a size?
Decrease.
Decrease. So can A be my answer?
No.
Cannot. Now look at the second one. Increase the volume. Is the volume part of any 4 factors I taught you?
No.
No, cannot. Again, you see the word volume in C. Is there any 4 factors I taught you?
No.
No, sir.
No, cannot. And then the last one, increase the temperature. Is it my 4 factors?
Yeah.
Yes.
Very good. Therefore, the answer will be D. Okay. Now let's go to question 36. The decomposition of hydrogen peroxide is catalyzed by manganese peroxide. How can a catalyst increase the rate of reaction? How does a catalyst increase the rate of reaction? Who wants to help me with this? I'm not going to give the answer. You tell me.
Increase the total number of reactant particles.
A catalyst can never increase
Activation
the
energy,
total
sir.
number.
A.
B.
D.
Okay, I want to tell you something. Kalau you kata jawapan you A, jawapan you sangat salah. Okay, because this is, for example, your activation energy. Okay, and already people the reactant so difficult to climb the activation energy. Kalau you increase lagi, they are going to climb Mount Everest. Who wants to go and there will be no reaction happening. What you want
Okay,
is
okay.
Zawawi, you got 2 devices, is it, Zawawi?
Yeah.
Then you
Keep them
are
away there.
echoing. Oh, you
Can hear the
mute
echo.
one.
Yeah.
You mute one.
Yeah, mute one.
Why you want to make me happy? Is it by putting 2 devices so more people in the class? Is it? His laugh also echoed. My goodness. Okay, so the catalyst, if you remember, catalyst punya definition. What is it? What is the
To
catalyst?
make
To
reaction
make the
faster.
reaction faster, yeah.
No, you don't want to make the reactant go faster. You are never going to do that.
No, reaction.
Make the reaction happen.
No. Actually, a catalyst will increase the rate of reaction. Okay, you are increasing the rate of reaction. How? Okay, now imagine this
Lowering
is,
the activation.
yes, okay, imagine this is Mount Kinabalu. Okay, the activation, if I have a catalyst, the catalyst gives a shortcut, okay, to climb, so lower the activation energy. It's an alternative pathway, so they don't have to climb up so high. Okay, they can climb a lower activation energy and more particles can become reactants. Can become products. Does that make sense to you all?
Yes, teacher.
Yes.
Okay, so for example, I tell you from your class, go to 4A class. Okay, but I give you all a horrible task. I say, from your class, I want you to climb an imaginary stairs upstairs. Okay, fly all the way to their class and then drop on the roof and fall down. It seems very difficult, isn't it?
Yes.
If any of you can fly lah. Okay. So what will be the best answer here? So actually the most easiest way is when you actually take the normal way to go to your class from 4A to 4B. You all just go the normal shortcut, correct or not?
Yes.
Okay, that normal shortcut is this lowered activation energy. So more of you will be able to go to 4A class compared to many of you who must climb an imaginary staircase, and you, after climbing the imaginary staircase, then you fly and then you drop in the roof. No one can do that. Okay, are you following what teacher is saying?
Yes, teacher.
Okay, so the answer is B. Okay, now can I have someone answering me for the next one?
Is it D?
Says the answer B. Can continue the class.
Is D?
Why is teacher muted?
The answer is B.
B, yeah.
Sorry, I was in a call. I'm so sorry. Okay, 37. The answer is, what is the characteristics of a catalyst?
D.
D, correct. The mass will remain the same. Okay. Next one. Which one is the following is the characteristic of the catalyst? Which one is this? So will it change the amount of product? Can a catalyst change the amount of a product?
No.
It can never change the amount of the product. Will it be chemically unchanged? Can a catalyst be chemically unchanged?
No.
Okay, never. So your answer will be B. Okay. Correct. Okay. So which manufacturing of the following is not a characteristic of a catalyst? So Again, what is the best answer here?
B.
B.
B, very good. It can never influence the quantity of a product. Okay. Now, how does a catalyst increase the rate of reaction? How? Think properly.
A.
A, yes, correct.
A,
Okay.
yeah.
Very good. The catalyst will lower the activation energy, provide the alternating pathway, more particles can collide, so my number of effective collision increases. Correct. Okay, this is the one that I've been wanting to tell you. Okay, the bouquet. Okay, now activation energy is always from where to where?
Reactant to product.
Very good. Dinesh, good job. Now, which one is the reactant to product? Tell me. A, B, C, or D?
A, teacher.
Okay, every one of you, do you know what Dinesh is saying? Do you understand?
No, sir.
Okay, besides the PM, anyone else who doesn't understand?
Teacher.
Okay, so whenever teachers say activation energy, if I'm drawing the energy here, okay, all right, and then here is my reaction path, all right. Usually, I will always have the reactants here, okay. For example, HCl plus NaOH, okay, they are going to collide with one another. After they collide with one another, they must have an activation energy. Remember, in order for a reaction to happen, I must have three conditions. Number one, they must collide. Number two, they must have energy more than the activation energy, correct?
Yes.
And the third point is they must collide at the right orientation. So here they can collide already very well, okay? And then here will be my products. So here I'll get NaCl plus water. Now, if my two products here are colliding with one another, let's say they collide with one another, and they have enough energy to overcome the activation energy. This whole thing here is called activation energy. So these are my reactants. The reactant is always, the activation energy is always the reactant to the peak. This is called activation energy. Does that make sense to you all now, Sanjeev?
Yes.
Yes, yes.
Okay, the activation energy must be, okay, from my reactant to the peak. Because your reactant is the one that must have the energy to overcome the activation energy. You look at B, it's going downwards for what? You look at C, it is going somewhere else. You look at D, going somewhere else, I don't want, okay? It must be from my reaction to my, okay, to my screen. All right, so that will be my answer. What is my answer, class? A.
A, teacher.
Okay, good job. Okay, move on. 42. What can change the activation energy from A to A prime?
Catalyst.
B.
Very
Catalyst.
good. Good job. Catalyst. Only catalyst, you remember? Only catalyst can change the activation energy. Who is by there?
Me, teacher, me.
Bila nak buka sekolah, if he can answer you, let me know lah. Okay, now show me, which one shows me the lowest activation energy? Lowest.
Ball.
Yeah, I say A, teacher.
Okay, the answer is A, yes. Why? Because I must count. This one is 300 to 200. This one is here to here. Okay, this one is from the reactant to the product. This one is a lot, cannot. This one is from here to here, too much. Okay, so it's between my A and B. And of course, you can see very clearly my A is the least. Can you all see that?
Yes, teacher.
The
Yes,
rest
I
of
can.
you?
Yep, yep, yep.
Okay, good. Now, when I add a few drops of copper 2 sulfate, what is my copper 2 sulfate?
Catalyst.
Reactant.
Catalyst. Very good. Cannot be reactant. Catalyst. Okay. Copper 2 sulfate is always for zinc plus sulfuric acid. To make the reaction go faster, I put copper 2 sulfate. Okay. Which statement tells me why the reaction increases? Okay. Tell teacher which one.
Lower the
Lowest
activation.
activation energy.
Very good. A. So easy the answer. Huh? Okay. Let's go to 45. 2 grams of manganese oxide is added to hydrogen peroxide. What is the difference with adding catalyst and not adding catalyst? What's the difference?
Concentration.
Yeah.
No, nothing to do with concentration.
Body.
Adding the catalyst can only affect one thing.
Heat. Temperature. No.
What's the answer?
D.
D, correct. Good job, Ane. Okay. The catalyst or any factor will affect the rate of reaction. Okay, good job. Okay, next one. Which factor does not affect the rate of reaction?
D.
Senang.
Volume of the reactor.
Very good. Volume, I told you must have only the factors that I gave. Now this product, okay, they are responsible to overcome the problem here. What should they do?
D. Increase the temperature of the production.
Correct.
process.
It is my, again, whenever I want to talk about rate of reaction, I must talk about my factors. I go to bigger size. Is bigger size better or worse?
Worse.
Okay, worse. Why? I must use small size or big size?
Small.
Small.
Small size.
Okay, good. The next one. Do I need to increase, is volume part of my factor?
No.
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 And then for sulfuric acid, you must use vanadium oxide. It's specific. You cannot use platinum. Out. Okay, so the best answer is D. Okay, let's go to 48. Okay, I have got 2 experiments. Okay, one with for the decomposition of hydrogen peroxide in the presence of a catalyst. Okay, I got 1, I got 2. Okay, one is using 50 centimeter cube 1.0 mole. So this bottom one here is 1.0 mole decimeter cube. Okay, the temperature is 21 degrees Celsius. Okay, what do you think is the one for B, number 2 here? Okay, what must be number 2? So this one you must find out. It must give me a higher rate of reaction. Okay, it must give me a higher rate of reaction. So how to do this?
The same method actually.
So you must actually, yes, you know. Okay, we go one by one. We do A first. I need to see, because you see they are meeting back at the end here. I need to make sure my number of moles is the same. Okay, can everyone calculate for me? 50 times 1 divided by 1000 times 24,000. What do I get? 50 times 1 divided by 1000. How much is it?
1200.
Okay, this is 1200. What is my number of moles first? 0.05 mole, right?
5. Yeah.
All of you agree?
Yes.
Okay, so I'm getting
Yes.
1200. Okay, and I'm using 0.05 mole. Okay, and remember, experiment 1 is 1 mole per decimeter cube. Okay, now I want all of you to now go and do for me A, 25 times 0.5. Okay, 25 times 0.5 divided by 1 times 24,000.
0.0125.
The number of mole, is it?
Yes, yeah.
Okay,
Yeah,
0.0125. Okay, look at the number of mole. Okay, 0.0125. Okay, now times 24,000.
300.
Okay, do you think it will be A the answer? Do you think it's reaching?
No.
Okay, so A memang cannot. Now do B for me. Do B for teacher. 25 times 1 divided by 1000 times 24,000.
600.
600. Is it reaching 1000 too?
No.
No. Try the next one. 50 times 0.5 divided by 1000 times 24,000.
So I get 600.
Anybody else? Should be correct. It should be 600. Anyone else who calculated quickly?
Yeah.
Yeah, 600.
Okay, 600. Okay, now every one of you do for me the last one.
The last one 1200.
Okay,
Fine.
memang 1200. Okay, but okay, so you might be thinking, teacher, I think the answer is D. Yes, correct. So for this part, I only got for here. Okay, now I want to confirm that my rate of reaction is memang higher. Then I look at the temperature. For experiment 1, my temperature is 21. For experiment 2, my temperature is higher, which is 30. Do you think it's best fit?
Yes.
Yes, because the temperature is higher than 21. So yes, then my answer is D. You see how to answer this kind of questions, class?
Yes, dear.
Okay, now you understand better, right? Actually, it's not difficult, correct or not? You just need
Yep.
to know the method to it. Okay, now how can I increase the rate of reaction? Number 49.
A. Decrease the size of zinc.
Very good. Okay, I want to decrease the size. When size is smaller, rate of reaction is higher. Volume not a part of it. Temperature cannot. To increase the rate of reaction, I must always increase the temperature. Same thing for concentration. I want to increase rate of reaction, I must increase the concentration. Are you following, teacher?
Yes,
Yes.
dear.
Okay, good.
Yes,
Six
sir.
more. Six more. The equation below shows a reaction to produce hydrogen gas. Which one can increase the rate of production?
D. Increase the temperature of the mixture.
Okay, everyone agrees with Chia or anybody want to membangkang Chia?
No, it's
No, teacher.
Is the answer correct or not? Chia's answer.
No, I say it's wrong, teacher.
Okay, Tinish says wrong. Okay, anyone else? Tinish, if you
Wait,
say
what
it's
was
wrong, then
answer
what is
again?
the answer?
No, I think it's C, teacher.
You say C. Okay, Jeff?
Size of it. Ow.
The size need to be smaller.
Never mind. Shortly, teacher will discuss. Anik, what's your answer, Anik?
The pot chia.
Sorry?
D.
D. Okay.
Yeah, could be.
Zawawi put B. Okay. Let me see. Renat, what do you put? Renat, what did you put?